Bismillahirrahmanirrahim. Assalamu alaikum. Lecture number 10, unit number 1, complex number. The topic of this video lecture is system of simultaneous linear equation. System of simultaneous linear equations with complex coefficient. So in this video lecture we will discuss that what is the system of simultaneous linear equations with complex coefficient and how we can find out the solution of such systems. The solution is actually the values of the unknown which involved in the system. So our target is, in this video lecture, our target is to find the solution of the prior system. How we can find out the solution of the prior system? So first of all, we need to discuss briefly that what is the system of simultaneous linear equation with complex coefficient. Now before to discuss the system of simultaneous linear equation with complex coefficient, we briefly revise the idea which is discussed in the previous video lecture, that is linear equation in two variable. This is the background knowledge for this topic which already discussed in the previous video lecture. Background knowledge for this video lecture. You people know that linear equation in two variable. Let's say if I write 2x plus 4y equal to 8. So this is a linear equation in two variable. In this equation you clearly see that there are two variables and this equation is linear because the highest power of the variable in these both term are 1. Highest power of the x is also 1, highest power of the y is also 1. So this is a linear equation in two variable. This is a linear equation in two variables. The standard form of linear equation in two variable is ax plus by plus c equal to 0, where a is not equal to 0, b is not equal to 0, and a, b, c are from the set of real numbers. Now you clearly see that this is a linear equation in two variable. So in previous video lecture we discussed that linear equation in two variable geometrically represent a straight line. So the geometrically 2x plus 4y equal to 8 represents a straight line, or any type of linear equation in two variable will represent a straight line. So how you can draw the graph of this straight line? You know that for a line, minimum requirement to draw a line is to plot 2 points in a plane, and passing a straight line from the 2 points you get the graph of the line, you get the curve of that line. So the minimum requirement to draw a line, minimum requirement to draw a line in two-dimensional plane or 2 points in a plane, mean you need to plot 2 points in a plane and then join those 2 points and extend that line in both the direction, that line segment in both the directions, so you will get a line. So for example, how we can, so now to find the 2 points in a plane, you need to find out the x-intercept and the y-intercept. For example, let's say this is my rectangular coordinate system. I already explained this, that why we consider this rectangular coordinate system, because you need a reference point from where you need to start the measurement. So let's say this is the x-axis, and let's say this is the y-axis. The horizontal axis is called x-axis and the vertical axis are called y-axis. Now you need to plot, you need to find out the coordinates of the 2 point in a plane. You already know that there is a 1-1 correspondence between the set of the ordered pairs and the points of the plane. So you need to find out the ordered pairs of the 2 points in a plane, which shows the coordinate of their 2 points. For that, you may find their 2 points, or you may plot their 2 points anywhere in this plane. But the simple and the easy way is that you know that if I draw a line here in this plane, if I draw a line like like this or like this, so that line will pass from x-axis as well as from y-axis. So the point at which the line passes from the x-axis and the is called the x-intercept of that line, and the line which passes from the y-axis is called the y-intercept of the line. So if you need 2 points in a plane for the graph of the line, so it is now obvious, you just need to draw, you just need to find out the x-intercept and the y-intercept of the line, that the line passing from the x-axis and the line passes from the y-axis. So if you find out the x-intercept and y-intercept, then pass a line from that, so you will get the graph of that equation, you will get the line for that equation. So for x-intercept, remember, when you are finding x-intercept, you need to suppose y equal to 0, because you know that on x-axis the value of the y is 0. On x-axis there is no vertical distance. You clearly see that this is a horizontal line. So for x-intercept, you need to put y equal to 0. So when y equal to 0 in this equation, when you put y equal to 0, so 2x is equal to 8, so this implies that x is equal to 4. So this 4 0 is your x-intercept. So let's say this is 4 0, let's say this is 4 0. So this is my x-intercept, this point is my x-intercept, mean the line is passing from the x-axis from this point, mean this is the point of intersection of the line with the x-axis. Now for y-intercept, put x is equal to 0, because on the y-axis there is no horizontal distance, y-axis is a vertical line, so that's why on this line the value of the x coordinate must be 0. So when you put x is equal to 0 in this equation, so 4y equal to 8, so you will get y equal to 2. So 0 2 is your y-intercept. So let's say this is 0 2, let's say this is 0 2. So now you see that this is the x-intercept and this is the y-intercept of this line. So if you need to draw the line, per line we already discussed that we need minimally 2 points in a plane. So now you see that these are the 2 points in a plane. So join these 2 points or pass a line from these 2 points. So you see that this is the line. So you clearly see that this is the graph of this equation. So in short, we can say that linear equation in 2 variables graphically represent a straight line. Linear equation in 2 variables represent a straight line in 2-dimensional plane. Now remember, this line is a graph for this equation. So any point lying on this graph is the solution of this equation. Remember that when you draw the graph of any equation, So all the points which make the graph will satisfy that equation. It means that any point lying on the graph of the equation is actually the solution for that equation. So from here we can say that all the points which make this line, or you can say all the points lies on this line, is the solution of this equation. Now what is the solution of this equation? The value of x and the value of y which satisfy this equation. Now in this on this line, if you consider any point on this line anywhere, so that point is actually the point which lies in a plane. That is the point of a plane, and every point of a plane has some ordered pair for their coordinates, for their position. So if I choose this point, so this point has some distance on x-axis and some distance on y-axis. So this point has two coordinates. Let's say the x coordinate is x1 and the y coordinate is y1. It may be some specific values. So those specific values when replaced in this equation for x and for y, so you will get left hand side equal to right hand side. Those values will satisfy this equation. So remember, all the values, all the points on the graph of the equation is actually solution. So in this case, this equation has infinite solutions. This equation has infinite solution because every point on the line is the solution of this equation, because this line is the graph of this equation. And I already explained to you that when you draw the graph of a equation, so all the points which make that graph, or all the points which lies on the graph of the equation, is actually solution for that equation. So in this case, this equation has infinitely many solutions, infinite solutions. Now why this equation has infinite solution? If I consider this equation, let's say 3x plus 4 equal to 0. So this equation has a unique solution, minus 4 by 3. This has only one solution. Now why the solution of these equations are infinite? Because in this equation, if you see that the number of equation are 1, the number of variable is 1. So when the number of equation and the number of variables are equal, then we get unique solution. So this is the unique solution. But when the number of variables are greater than the number of equation, for example in this case you see that the number of variables are 2 and the number of equation is 1, so in this case you get infinitely many solutions. Now you clearly see that this line is made from infinitely many points, so that's why every point lying on this line is the solution of this. So that's why I am saying that the solution of this line is infinite solutions. So this is the graph of, so from this discussion you need to remember 2 points, that the linear equation in 2 variable graphically represent a straight line, and whenever you draw the graph of any equation, so all the points lying on the graph will satisfy that equation. Mean all the solutions of that equation is actually make the graph of that equation. So these 2 points you must need to remember. Now moving towards the system, we previously also discussed that when you write 2 equations togetherly, 2 or more than 2 equations togetherly, if I, for example, if I write let's say x plus y equal to 3, and let's say 2x plus 3y equal to 9. So this is called system, because in this you write 2 equations combinedly. So when you write 2 or more than 2 equations combinedly, this is called a system. But now this system contains 2 equations, and both the equations are linear equations in 2 variable. So I can say that this is the system of linear equations, because the system contains 2 linear equations. So this is system of linear equations in 2 variables, Now what is the solution of this system? Solution mean you need to find out the value of x and the value of y. So that must be in ordered fair form, because you know that the graph of this equation is a straight line, the graph of this equation is a straight line. Now in this case, the solution means those values of x and y which satisfies this equation as well as this equation. So when a system is satisfied for the single values of variable, such system is called simultaneous system. So now if I find the solution of this system, so for that I will use the equating coefficient method. Now in this case you see that this is a coefficient of x, and this is the coefficient of y. The coefficient of x in equation number 2, let's say this is 2, the coefficient of y is 3. So I need to make the coefficient equal of one of the variable in this system. So let's say I multiply this equation with 2, so that will become 2x plus 2y equal to 6, and the second equation is 2x plus 3y equal to 9. So you clearly see that when I multiply 2 with this equation, the coefficient of x in both the equations will become equal. So now just subtract equation 2 from equation number 1. This is, let's say, equation 1, and this is equation 2. So this will be cancelled. From here you get minus y, and from here you get minus 3, so y is equal to 3. So you clearly see that when you make the coefficient equal of one variable, so by adding or subtracting, that that variable is eliminated, and now then substitute y equal to 3 in one of the equations, so you will get the value of x. So this method is also called method of elimination and substitution. You clearly see that I eliminate x by equating the coefficient of one of the variable, and then you get the value of the other variable, and that value will be substituted in one of the equation to get the value of the x. So let's say I put this value in equation number, let's say this is my equation, I put this value here. So this is x plus 3 equal to 3, so it means that x is equal to 0. So now 0, 3 is the solution for this system. 0, 3 is actually the point in a plane. This is the point in a plane. This is the point in a plane. Now you see that I am draw this point in a plane. Let's say this is my rectangular coordinate system. Let's say this is y-axis, this is x-axis, this is x-axis. Now 0, 3. So this is the reference point. 0, 0. 0, 3 is a point lying on the y-axis, because this point has x coordinate 0, mean this point has no distance on the x-axis and 3 unit distance on the y-axis plus 3. So this will be upward from the reference point. So let's say this is 1, let's say this is 2, and let's say this is 3. So you see that this is 0, 3. So this is the point in a plane which actually satisfies both the equation. If I put 0, 3 here, 0 for x and 3 for y, so you clearly see that 0 plus 3 equal to 3, 3 equal to 3. So for 0, 3 this equation is satisfied. If I put this 0, 3 in this equation, so 2 multiplied by 0 plus 3 multiplied by 3 equal to 9. So 9 equal to 9. This is 0, 3 multiplied by 3. So this point also satisfies this equation. Mean this is also the solution of this, and this is also the solution of this. What does it mean? It means that this point must lie on this line as well as this point must lie on this line, because you know that these are the linear equation in two variables, and you know that linear equation in two variables is actually represent a straight line. So if they are straight line, so both these straight lines will pass from this point. Mean actually this point is the point of intersection for both the lines. So if this point is the point of intersection for the both lines, so this point lies on the both lines. So if this point lies on the both lines, mean this point lies on the graphs of both the equations. So we already discussed that a point lies on the graph is actually the solution. So in this case you see that this system is satisfied for the single value of x and for the single value of y. Equation number 1, let's say, is also satisfied for this. Equation number 2 is also satisfied for this. So such type of systems are called simultaneous. So the full name of this system will be system of simultaneous system of simultaneous linear equation with in two variable with real coefficients. In this case, you see that there are real coefficients. The constants mean the coefficients and the constants are from the set of real number. Now I am drawing the graph of these two equations. So how I can draw the graph of x plus y equal to 3? You need to find out the x-intercept. So for x-intercept, put y equal to 0, because x-intercept mean the point on the x-axis, which is the point of intersection with the line. So that's why you will put y equal to 0. So you will get x is equal to 3. So this is 3, 0 is the x-intercept. So let's say this is 1, this is 2, this is 3. So this is 3, 0. This is the x-intercept for this line. Now I am finding for y-intercept. I put x is equal to 0. So when x is equal to 0, y will be 3. If you put x equal to 0 in this equation, you will get y equal to 3. So now this is 0, 3. So this is another point. So pass a line from these 2 points. Now I am passing a line because the minimum requirement for the line are 2 points. So you see that this is the graph of this equation. This is the graph of this equation. Now draw the graph of another equation, 2x plus 3y equal to 9. Draw the graph of this equation. So for x-intercept, put y equal to 0. So when y equal to 0, so this 2x is equal to 9, mean x is equal to 9 by 2. So x will be equal to 4.5. So this is your x, 4.50. So if this is 3, let's say this is 4, and let's say this is 4.5. So this is 4.50. This is the x-intercept. This is the x-intercept for this line. Now for y-intercept, put x equal to 0. When x is equal to 0, so 3y equal to 9, mean y equal to 3. So you see that 0, 3. So this is 0, 3. So this is the y-intercept. So pass a line from these 2 points. Now you see that pass a line from these 2 points. This is the graph of these two equations. Mean this is the graph of this system. Now you clearly see that this point lies on this line as well as on this line. Mean this is the point of intersection of these two lines. So if this point lies on the both lines, so it means that this point will satisfy both the equation, and this is the solution. So graphically you can also see that 0, 3 is the solution, and analytically I also start by using the method of elimination and substitution to get the ordered pair 0, 3, which is the solution of this system. Mean this value satisfies both the equation. So you see the graphical solution as well as the analytical solution for the system of linear equation in two variables with real coefficient. So this system is called the system of simultaneous linear equation in two variables with real coefficients, or you can say that real constants. Now this is the whole. I discussed one another thing, and then we will switch to the main topic. Our topic is just these coefficients will become complex, and the variable is also a complex. Now we know that the complex number, every number is a complex number. So this system is also said to be a system of simultaneous linear equation in two variable with complex coefficient. But these in some situation you can also deal with the coefficients with maybe 2 plus iota or 3 plus iota or minus iota. So then how we can find out how we can solve that systems. But before to discuss that, you need to consider, I am considering 3 examples. Now in this discussion, this system has a unique solution. this system has a unique solution. You clearly see that this system has a unique solution, mean there is a single value of x and single value of y which satisfies both the equation, mean this single point in a plane having coordinates 0, 3 is the solution of this system because this point lies on both the lines. So this system has unique solution. So when a system has a unique solution, that system is called consistent system. Now note, this is an important point which is not discussed in the book. An important point for eta, important point for engineering test. What is consistent system? Consistent system. Now you know what is system. If a system has unique mean one solution, so that system is called consistent system. For example, that we discussed in the previous example, that example is x plus y equal to 3, 2x plus 3y equal to 9. So this system is consistent system because this system has a unique solution. I also bind analytically and I also show graphically that this system has a unique solution, and the solution of this system is a point of the plane having coordinate 0, 3. This is the solution of this system. And graphically we show that, let's say this is 0, 3. So both the lines passes from this point. So this is a consistent system. Now second, if a system has infinite solutions, so that system is also be a consistent system. Now what is the example of that system? I am considering the example if a system has one solution or if a system has infinite solutions, so that system is also called consistent system. Considering an example, 2x plus 4y equal to 8, 8x plus 16y equal to 32. This is a system of linear equation in two variable, and this is a simultaneous linear system. So this is system of simultaneous linear equations in two variables. So if you solve this by using the method of elimination and substitution, by equating the coefficient of one of the variable and then adding or subtracting to get the value of one variable and then substitute that value in one of this equation, you get the value of another variable, or you can draw the graph. So from the graph you will get a clear picture that how this system has infinite solutions. Now the graph of this line and the graph of this the graph of these two equations are actually lines. So I am considering first this one and need to draw the graph of this. So for x-intercept put y equal to 0, so x will become 4. So 4, 0 is the x-intercept. You see that, let's say this is x-axis, this is y-axis, so the x-intercept is 4, 0. When you put y equal to 0, so 2x is equal to 8 mean x is equal to 8 by 2 mean x is equal to 4. So let's say this is 4 0 is the x-intercept of this line, mean this line passes from x-axis through this point. For y-intercept, for y-intercept, for y-intercept, for y-intercept, put x equal to 0, so y will be equal to 2. So this is 0 2 is your y-intercept. Let's say this is 0 2. So this is the y-intercept. Now pass a line from these 2 points, so that will be the line of this equation, mean that line will be the graphical representation of this equation. So you see that I am passing a line, this is a line of this equation. So all the point lies on this line is actually the solution of this. So there are infinite solution, mean the line is made from infinitely many points. So that's why for this equation every point on the line is the solution. Now consider the second line. If you consider the second line, so there it is 8x plus 16y equal to 32. So for x-intercept, for x-intercept, sorry, for x-intercept, for x-intercept, put y equal to 0. So when I put y equal to 0, so 8x is equal to 32. So x is equal to 32 divided by 8. So mean x is equal to 4. So 4 0 is the 4 0 4 0 is the x-intercept for this line as well. And now for y-intercept, put x equal to 0, so y equal to 4, so y will be equal to 2, because when you put x equal to 0, so 8 multiplied by 0 0, 16y will be equal to 32, so y will be 32 divided by 16, mean y equal to 2. So 0 2 is the y-intercept. So now the line, the graph of this line is actually lies on this line. Both, you see that these are two lines, actually one line is lying on the other line. You see that let's say this black pen is the line for this equation, and let's say the red pen is the line for this equation. So both the line lies on each other, both the lines lies on each other. So you see that there are infinite, all the points are actually lies on each other, so there are infinite intersections. In this case you see that there is a single point of intersection, so that point lies on both the lines, so that point satisfies both the equations. So that's why this system has a unique solution. Now in this case both the lines lying on each other mean there are infinite point of intersection, so that's why there are infinite solutions. Every point lying on this line or on this line will satisfy both the equations, so that's why this system has infinitely many solutions. Actually if you see to these two equations, this equation is actually a multiple of this equation. If you multiply this equation by 4, you will get this equation. So when one equation is the multiple of other, you clearly see that this is equation number 1 of this system, and if you multiply this equation with 4, you will get, with 4 on both sides, you will get the second equation. So you can say that this second equation is actually a multiple of first equation. So whenever one equation is a multiple of other equation in a system, so in that situation we get infinitely many solutions, So in this case this system has infinite solutions, and in this case the system has unique solutions. So in both cases, if a system has infinite solutions, or if a system has unique solution, In both cases, the systems are said to be consistent system. And if a system has no solution, then that system is called inconsistent system. Inconsistent system. Inconsistent system. Consistent system. The video becoming lengthy, but these points must be discussed because these points are included in your course. Now, after discussing the inconsistent system, I will show you a factor in your book, and they just gave the factor and there is no detail. But you must remember these things. You must note these things for the conceptual study and for the upcoming exams when you gave for entrance test in university. So that's why I am discussing these points. Now, inconsistent system. If I consider an example, let's say 2x plus 4y equal to 8, 8x plus 16y equal to 16. So the x-intercept for this is the x-intercept for here. Now find out the x-intercept for this. So x-intercept mean y equal to 0, so x will become 4. So 4 0 is the x-intercept. So let's say this is 4 0. And y-intercept for this equation, so put x is equal to 0, y will be 2. So let's say this is 0.02. So this is the graph of this equation number 1 of the system. This is the graph of this equation. Now for this, the x-intercept is put y equal to 0, x will be equal to 2. So 0 2 or 2 0, sorry. So this is your point 2 0 is the x-intercept for this, and the y-intercept put x equal to 0. So when x equal to 0, so y will be equal to 1. So 0 1 is the, so this is the point 0 1, this is the point 0 1. So this is the y-intercept and this is the x-intercept of this line. So now you see that if I join these 2 points or force a line from these 2 points, so these two lines are parallel to each other. There is no intersection. You cannot find a point which lies on both the lines. If a point lies on both the lines, so that satisfies both the equation, because every point on the graph is actually the solution of that equation. So now in this case you clearly see that there is no point of intersection. These lines are parallel. So if there is no point of intersection, so there is no solution for this system. You cannot find the value of x and the value of y which satisfy this equation as well as this equation. So that's why this system has no solution. So if a system has no solution, then that system is called inconsistent system. That system is called inconsistent system. So if a system has no solution, then that system is called inconsistent system. So now you see a picture in your book on page number 19. This factor, this is no solution because the lines are parallel, and so this is inconsistent system. Consistent system, dependent, and this is independent, and this is dependent. Now in this case this is the point of intersection, so there is one solution, unique solution, and in that case one line lies on the other line. So there are, this infinity mean infinite solutions, infinite solutions. This infinity, this is the notation for infinity. So you see that this picture is just given in your book and there is no other explanation for this picture. So I explained this in detail, which is necessary for you conceptual study. So this is the consistent system and inconsistent system. Now switching towards the problem. Now in this case, this is a system of simultaneous linear equation with complex coefficient. Now you see that this is a equation in two variable. This is also equation containing two variables. So when you see that two equations are written combinedly, so this is a system, and this is a simultaneous system, because when you get the value of z and the value of w, which is the variable, so that variable will satisfy equation 1 as well as equation number 2. So let's say this is a system star. So this is a system. Now the coefficients are from the set of complex numbers. These coefficients are from the set of complex number. Now you see the example. So how you can find out the solutions, how you can find how you can solve this? You need to equate the coefficient. You need to multiply equation. Let's say this is equation number 1, and let's say this is equation number 2, and the system is, let's say, star. So multiply equation 1 by 2 minus iota and equation 2 by 5 to get the coefficient, to equate the coefficient of z. If you want to equate the coefficient of w, so you need to multiply this equation 1 by 2 iota and equation 2 by minus times 3 plus iota. So you will then add or subtract, so that variable will be eliminated. That variable will be eliminated and you will get the value of z, and that value of z will be substituted in equation 1 or equation 2. You will get the value of w. So you can solve this by the previous method that we discussed in the previous lecture as well as in this lecture. So this is the target. You need to find out the solutions of this such systems. So you see that I briefly discussed this. Now you see this method will be used. Method of elimination and substitution will be used. Method for the solution of the system of simultaneous linear equation with complex coefficient in two complex variables z and w. So this method will be used. Now I am considering an example. You see that this is an example. This is an example. You clearly see that this example, you clearly see this example is 5z minus multiplied by 3 plus iota into z equal to 7 minus iota, 2 minus iota multiplied by z plus 2 iota multiplied by w is equal to minus 1 plus iota. So this is a system of simultaneous linear equation with complex coefficients. Now the coefficients of the variable are complex. If you say 5 is a real, so you know that every number is a complex number. Now you discuss the set of complex number. So in this case we will say these coefficients are from the set of complex number. The constants are also from the set of complex number. This is the value of p1, this is q1, p2, q2, r1, r2. So z and w will be also complex variables. These are unknown. We need to find out the value of z and the value of w, and that ordered pair must be a point in a complex plane. You see that this ordered pair must be a point in a complex plane. So this is the whole idea of this topic. Now moving toward the exercise 1.3, question number 1. Now if you see to the example, this is example, I solved this example. So now you see that this is a system. I need the value of w and z, so I need to equate the coefficient of z or equate the coefficient of w. So if I want to equate the coefficient of z, I need to multiply equation number 1 with 2 minus iota and equation number 2 with 5. So you see that I multiply equation 1 with 2 minus iota, whole equation with 2 minus iota. This term and this term whole will be multiplied by 2 minus iota, and equation number 2 by 5. So 5 will be multiplied here, here and here. So you see that the coefficient of the z are equal. 5 multiplied by 2 minus iota, 5 multiplied by 2 minus iota. In both the equations the coefficient of the z are equal, have same sign, so that's why I am subtracting this one from this, mean equation 1 from equation 2. So these two will be cancelled out. You will get this and you will get this. Now just simplify this. You will get the value of w. Now put the value of w in equation 1 or equation 2. You will get the value of z, you will get the value of z. So this is the whole procedure. Now in this case, this system is a consistent system because this has a unique solution. So the ordered pair 1 plus iota and 2 iota, 1 plus iota and 2 iota is actually the solution of this system. 1 plus iota and 2 iota is the solution of this system. So if you put in place of z 1 plus iota and in place of w 2 iota in equation 1 or in equation 2, left hand side will be equal to right hand side. So this is the solution of this system. So this is the method of elimination and substitution. First of all, you see that the z is eliminated, and then you get the value of w, and that value of w is substituted in one of the equation to get the value of z. So this method is called the method of elimination and substitution. The system is consistent because it has a unique solution. If a system has a unique solution or infinitely many solutions, such systems are called consistent system. So this is the example exercise 1.3. Solve the simultaneous linear equation with complex coefficients. So you see that this is your system. You see, this is your system. Z plus iota is equal to 3 iota, z plus w is equal to 3 iota, 2z plus 3w is equal to 2. So if you need to solve this, you need to equate the coefficient of one of the variable. So if you want to equate the coefficient of z, so you need to multiply 2 with this equation. So that will become 2z 2w equal to 6 iota. So 2z and 2z. You see that the equation, the coefficient of the z will be equated in both the equations. If you want to equate the coefficient of w, you need to multiply 3 with equation number 1. Let's say this is equation number 1. So you will get 3z plus 3w equal to 9 iota. So the coefficients of w will be equated. The signs are same, so you will subtract one equation from the other. So now the choice is yours. So I multiply equation 1 by 2 and then subtract 2 from it. So you see that you multiply 2 with equation number 1 and then do a subtraction, because in both the equations the coefficient of z have same sign, equal and same sign. So you will do subtraction. If they have equal same coefficients with different signs, so you will do addition. So from subtraction you will get w is equal to this. Now substitute this value in one of them, you will get the value of z. So in this case you see that this system also has a unique solution. So this system is also a consistent. Similarly, you can solve equation part number 2. This is a solution. You may see it from here. This is your assignment. So this is your assignment. Solve this and send through email. So this is your assignment. You can also take help from this. This is already solved here, so you can take help from here. Part number 3 is also similar. This is part number 3. This is also your assignment. This is also your assignment. You need to equate the coefficient of z or w and then do the addition or subtraction to get the value of the other variable, and then substitute that variable in one of the equation to get the value of the other. So this is the simple way. So this is part number 3. So these are 3 parts in exercise 1.3 question number 1. So this is about the system of simultaneous linear equation with complex coefficient. We discussed this in detail, so please study this. If you have any question, you may ask through WhatsApp or email. Thank you.